good evening, everyone, and thanks for staying up late with us tonight. Welcome to another week of Weather Extra. I'm meteorologist Jillian Grace. Here in Central Texas, we had a rather hot but quiet week, but it was a very different story out in the Atlantic. And so we begin our coverage tonight with the top weather story of this week, Hurricane Fiona and all the damage it caused in Puerto Rico. Now, Hurricane Fiona became the sixth named storm of the 2022 Atlantic hurricane season and eventually became the first major hurricane of the year, reaching winds of 130 miles an hour. Now, Fiona was the first storm this hurricane season to inflict significant damage on populated areas. Fiona officially made the first landfall in southwestern Puerto Rico on September 18th. Exactly 1 week ago. Fiona was a Category 1 hurricane at the time of landfall just after 2 p.m. Sunday with winds up to 85 miles an hour. Torrential rains across much of the island caused devastating flooding and landslides. Almost the entire island of Puerto Rico was left without water thanks to Fiona. This storm may have caused at least 8 deaths and also left millions without water. Fiona stripped pavement from roads, tore off roofs, and sent water pouring into homes. It also flooded 2 airports. National Guard troops had to rescue hundreds of people all across Puerto Rico who got stranded as the floodwaters rose, just like you're seeing here in this video. And Fiona dumped historical amounts of rain as it slowly moved across Puerto Rico. Most areas saw anywhere from between 6 to 20 inches, with some isolated areas seeing as much as 30 inches. As you can see, those fast-moving waters swept a bridge right away. Now, the bridge you see moving down the river was installed by the National Guard after Hurricane Maria hit back in 2017. Now, the blow from Fiona was made more devastating because Puerto Rico has yet to recover from Hurricane Maria, which killed nearly 3,000 people and destroyed the power grid back in 2017. The video you see on your screen shows the damage Maria left behind. 5 years later, more than 3,000 homes on the island are still covered by blue tarps, and now the island has to clean up again after Fiona. Now, after Fiona tore through Puerto Rico, she moved on to the Dominican Republic. Fiona made a second landfall on Monday, September 19th, around 2:30 in the morning along the eastern side of the island with sustained winds of 90 miles an hour, making the storm a strong Category 1. Fiona's strong winds brought down trees and power lines. More than 1 million people were left without running water in the Dominican Republic, and dozens of homes were destroyed. Heavy rainfall soaked the eastern portions of the island and created life-threatening flooding. Now, according to the county's Emergency Management Director of Operations, he said nearly 800 people were brought to safety by emergency workers during the storm. And after moving through the Dominican Republic, Fiona then moved back into the Atlantic and headed towards Turks and Caicos. And as you can see behind me, Fiona caused even more destruction. Now, Fiona quickly strengthened as it moved back into the warm waters of the Atlantic, becoming the first major hurricane of the season with winds up to 115 miles an hour, making the storm a Category 3. Now, Fiona moved through the eastern portions of the Turks and Caicos Islands early Tuesday morning on September 20th. The western part of Fiona's inner core appeared to have impacted the Grand Turk Island, and the storm moved almost directly over the Caicos Islands. But thankfully, Fiona's position kept the strongest winds away from the more populated and larger islands of Turks and Caicos. Now, Fiona continued her track through the Atlantic where conditions were favorable for the storm to remain a major hurricane. Thankfully, Fiona stayed away from the east coast of the United States because the storm continued to gain strength and eventually became a Category 4 hurricane with winds of 130 miles an hour. Now, Fiona created a very scary scene out in the middle of the ocean. Check out this incredible video captured by a sail drone explorer showing you at home what Hurricane Fiona's surf looked like from atop a 50-foot wave. Now, the storm's strong winds and heavy rainfall made it nearly impossible to see right in front of you with those monstrous waves crashing around. Fiona would then head towards Bermuda. Now, Fiona stayed far enough west to spare the island of Bermuda from a direct hit, but the storm still brought heavy rain, strong winds, and dangerous storm surge this past Thursday and Friday. Wind gusts still reached 103 miles per hour, according to the Bermuda Weather Service. But thankfully, Michelle Pitcher, the deputy director of the Bermuda Weather Service, said the territory appeared to be largely unscathed. And after Fiona pounded Bermuda with heavy rain and winds Friday, the storm quickly moved north and headed towards northeastern Canada late Friday into Saturday. One meteorologist in Nova Scotia said Fiona has the potential to be one of the most severe systems to have hit eastern Canada, and it did just that Take a look. Now, Fiona ripped through Canada's eastern seaboard at hurricane strength after making landfall in Nova Scotia early Saturday. Fierce winds and storm surge caused power outages for hundreds of thousands and washed away some coastal homes. Local police and residents have said conditions are like nothing we've ever seen and have never seen in their lifetime. There is so much destruction in that area. Now, hurricanes in Canada are somewhat rare, mostly because once the storms reach colder waters, they lose their main source of energy and become an extratropical cyclone. But those cyclones still can have hurricane strength winds, which is what took place in Atlantic Canada. We continue our coverage right after the break on Fiona. KWTX meteorologist Sean Bellafiore has an explanation on how Fiona transitioned from a major hurricane into an extratropical storm. We'll be right back.
Welcome back to this week's Weather Extra. It has been a pretty quiet week of weather here in Central Texas with a couple of record-setting high temperatures, but the weather has not been quiet across the rest of the northern hemisphere, and specifically talking about the tropics. We have had not only major Hurricane Fiona, but this week we're expecting probably major Hurricane Ian to be making a close approach, if not a landfall, into Florida. This is an overview of what we've seen so far this year. For a La Nina year, it's been exceptionally quiet. The fact that we're in the end of September and we're only at the ice storm is good news, but we have had some pretty devastating storms, including, of course, Fiona, and hopefully not Ian, but the odds of some damage and destruction from that are increasing as it approaches the southeastern U.S. this week. This is Hurricane Fiona. We're going to start at the beginning, pretty much, when it moved through Puerto Rico and Hispaniola. This is a hurricane, clearly defined, fast spinning storm, and the eye that you see there on your screen for a moment there, a clear sign of a hurricane. A hurricane is a warm chord storm. Think of the tropics. If you've ever been to the beach, maybe to the Caribbean, you know that it's warm, that it's humid. That's how these hurricanes operate. Warm chord storm. Now, think of a nor'easter. Nor'easter typically happens in late fall and in winter, a cold chord storm that brings a lot of snow. That's what happened with Fiona. It went from this warm chord storm into a cold chord storm as a cold front picked it up. There you go. And notice how that eye just disappears and it looks a whole lot more like a nor'easter than it does a hurricane. That is called an extratropical transition, or Fiona became a post-tropical storm. Couple of things happen whenever a system turns into a post-tropical system. First off, the reason why it did and why it became a cold chord storm is because we had this cold front on approach from the west. That front helped to pick it up, but of course, as the front interacted with Fiona, it brought it some cooler air, transitioning it into a post-tropical storm. But notice, still with winds of 105 miles per hour. Whenever you transition from a tropical storm to a post-tropical storm, the wind field expands, and that's what we saw in Canada. Widespread winds gusting over 50 miles per hour. To better explain why the wind field expands, we're actually going to go up into space. This is astronaut Mike Fossum demonstrating what's called angular momentum. So remember back to the hurricane, spinning very tightly, spinning very fast. The same thing happens up in space with what we call angular momentum. Notice his arms are very close to his body, kind of like a figure skater. You're going to see it in just one moment. But then as he moves his arms a little bit farther out, he slows down a bit. That's what happens when we transition from a tropical storm or a hurricane into an extratropical cyclone. It gets picked up by this much larger storm system, this much larger trough in the upper atmosphere that interacts with the storm's core, and instead of being a tight spinning hurricane, it transitions. It gets a lot bigger, and the wind field has to expand as a result. Something similar could happen with Ian as it approaches Florida later on this week, as another cold front could potentially sweep that system up. For more on Ian and, of course, the rest of Central Texas's weather, be sure to download our free KWTX weather app by scanning the QR code on your screen.
Welcome back to Weather Extra. We turn now to outer space as NASA is sharing a stunning view of Neptune and its rings taken by its James Webb Telescope. take a look. Now, it's the telescope's first image of Neptune, and it's the clearest view of the planet in more than 30 years when Voyager 2 flew by. Now, the telescope is providing a crisp new view of the planet's rings, and it's the first time NASA has seen them in infrared. The telescope picked up several bright, narrow rings as well as the fainter dust bands. As for that bright light in the upper middle image of the screen here, you can see that it's actually not a star. NASA says it's Neptune's large and unusual moon Triton, which reflects an average of 70% of the sunlight hitting it. Neptune has 14 known moons, and Webb picked up 7 of them. And after seeing those spectacular images of Neptune's rings, you may be wondering why some planets have rings and others don't. Well, Dan Smith has the how and why behind the perfect planetary setup in your moment of science.
Noted philosopher Beyonce once said, "If you liked it, then you should have put a ring on it." We're back out in space this week discovering how we get rings around some planets, but not others. Chances are you just thought of the planet Saturn. Well, Galileo discovered those rings back in 1610, and until the 1970s, we thought it was the only planet with rings. Turns out the other gas giants, Jupiter, Uranus, and Neptune, also have them. But why? In our gravity episode, we explored how every mass is attracted to every other mass in the universe to some degree, though it goes down a lot with distance. That includes one side of a planet being closer to a celestial body than the other side, and runs the risk of being torn apart by tidal forces like entering black holes, but a lot slower. Here's where distance really comes into play. Back in the 1840s, a French astronomer named Edouard Roche calculated the distance at which masses would either get torn apart and form rings around a planet, or stick to each other and start forming their own larger mass farther away. This Roche limit is about 2.5 times the radius of the larger body, usually a planet. That also factors in density. So if you have a bunch of loose rocks all scattered about, it's more likely to get ripped apart than a more solid object. Earth's moon is actually a great example of the latter. It's theorized it was formed when Earth was hit by what amounts to a rock the size of Mars. That's a pretty big rock. Some chunks of that debris formed temporary rings around Earth, but a lot of that decided to have a little get-together on our orbit far enough away from Earth and became more concentrated and well-rounded over time. Lucky for us, the moon is well outside its Roche limit to shear itself apart all over again. In fact, it's getting gradually farther from us. The Earth used to spin a lot faster than it does today, and the moon served to slow down our spin over the years, drifting farther away to compensate for conserving that momentum. That conservation is also why the moon is tidally locked, and us Earthlings have only ever seen one side of it from our home. So why do the gas giants have rings and not us? The inner planets of the solar system, us included, might be a bit shielded from more extreme impacts, so there's less debris to form rings, or more moons around the gas giants may mean more collisions. Or a lot of the icy rings simply melted being closer to the sun. Either way, even Mars will have rings of its own in due time. Its biggest moon, Phobos, is moving faster around Mars than the planet is spinning, so it's getting closer to reaching that Roche limit. In tens of millions of years, it'll shear itself apart, and whatever doesn't fall to the red planet will just keep spinning around it. For this week's Moment of Science, I'm Dan Smith.
And staying in outer space, in this week's Degrees of Science, meteorologist Brady Taylor chatted with Dr. Jesse Christensen, who is a planet hunter for NASA. Take a peek into their conversation.
Well, I want to welcome in Dr. Jesse Christensen, who has got one of the coolest job titles I think I've ever heard of. So I never heard of a planet hunter. So Dr. Christensen, what exactly does a planet hunter do?
A planet hunter looks for planets around other stars. So our sun is a star with 8 planets around it, and our sky is full of stars. So I look for planets around all of those stars.
You know, when we walk outside and at night and you look out in the sky, you're going to see the dots, and that's the stars out there. But we can't see planets because they're not putting off the light. How do you discover planets that are so far away from us?
Yeah, that's been the trick. So for thousands of years, we've wondered about planets around other stars, but they're very hard to see, as you say. So the most common methods of finding planets actually rely on the fact that planets change the light from the star that we see. So you go outside, you look up and look at all of those bright dots in the sky. If they have planets around them, sometimes the planet is lined up just right. So it actually eclipses the star and blocks some of the light. So it's actually a very simple measurement. We just measure the brightnesses of the stars over and over and over again and wait for a little dip when a planet might go in front. And we do that for thousands of stars. And eventually we find the systems that are lined up just right and we find planets.
So is that just an extreme waiting game, I guess? Because you've got to line it up just right and the timing right. So, I mean, I know y'all found a lot of planets, but how many do you think you've missed out there that just haven't lined up right?
That's the fun part. So the planets that you do find are kind of, showing you how many you haven't found, right? Like, so if you find a bunch of planets and you know that you missed a bunch because they weren't lined up right, then you can extrapolate, you can use math and say like, okay, that means that almost every star in our galaxy must have planets around it, given how many planets we found so far.
So for all the kids out there, you said fun and math all in the same sentence, so you're like me. Yeah. So speaking of finding planets, how many exoplanets have been discovered so far?
This year, we just hit over 5,000 confirmed planets around other stars, which is pretty exciting given that we only started finding them 30 years ago.
Wow. And I know you've personally discovered a good bit, right?
Yes, I've been lucky enough to work on some really exciting projects, including NASA's Kepler mission, and was lucky enough to lead some discoveries from that mission. So I think 66 of those 5,000 planets are planets that I get to claim as having discovered.
That's a pretty cool thing. You get to claim a planet. That's not many people get to do that. Now, speaking of the Kepler mission, what was the goal of that mission that y'all had with that telescope?
Yeah, so Kepler had a very specific goal, and it's kind of a question that humanity has been asking for a really long time. Kepler wanted to know how many planets out there are like the Earth. How common is the Earth? Do lots of stars have an Earth-like planet, or are they very rare? So Kepler looked at nearly 200,000 stars for 4 years, a waiting game, as you say, to see if we could find Earth-like planets. We weren't able to find any Earth-like planets with Kepler, but we were able to infer that planets like the Earth are probably quite common, which was very exciting because, again, the answer could have been that there was one. But what we believe is now that, up to half of the stars in the sky, like our sun, have a planet like Earth around them.
I don't know if it's more overwhelming or just exciting for you to think about how little y'all searched and how much you found compared to how much is still out there. Is that just a daunting deal or just something that you're so excited just running towards?
Sure, more the latter, definitely. And partly because we've searched so little and found so much, that just means the potential for, habitable real estate in our galaxy is so high. So many of these stars seem to have planets. Almost every star seems to have some kind of planets. And that just means if you think about our galaxy having 100 billion stars, that's 100 billion planets out there. And part of the cool thing so far in the last 30 years of discovering planets is how different they are from our solar system and from each other. So nature has gone out and just created this buffet of planets, and we're still just like at this start of the table feasting. There's just heaps more to go, and I'm very excited.
What's the most interesting discovery that you've made in your planet hunting so far?
Sure. So we have a system called K2-138, and I'm very sorry, all exoplanets have terrible names, but it was a system that we found using Kepler data. And one of the reasons I love it is because it was found by citizen scientists at home on their computers, just helping us look through Kepler data. And I was lucky enough to help set up the citizen science project and get to lead this discovery and publish the paper. But the planets themselves were found by citizen scientists at home. The reason the system is fairly exciting is it's got 6 planets in it, and the inner 5 planets are all small planets very close to their star, and they orbit in resonance. So a resonance is when the periods of the planets, those years, how long it takes them to go around, are related to each other by very simple integer ratios, for instance, 2-to-1. So the inner one goes around twice and the next one goes around once. And so what we see is this clockwork system of resonances of tiny planets all crammed in close together. And the only reason they can stay so close together is because they're in these really stable resonances. And the reason I love it is because it plays music. So resonances are intervals in music. And so you can actually turn these resonances into a song. And so it's a citizen science planet system that plays music.
Oh, that's awesome. We also heard the music that NASA put out about the black hole. That hopefully the music from that system is
cool.
not as creepy as the black hole music. So
no, the music from the KT-138 system is more like Twinkle Twinkle, more like a little melody. Yeah.
And to hear more about Dr. Christensen's cool job as a planet hunter and to hear other amazing conversations about weather, space, science, and how it affects us, scan the QR code on your screen to watch on YouTube or go to KWTX.com/degrees of science. And coming up after the break, powerful earthquakes hit part of Mexico. We have the incredible footage of when the earthquake hit. Stick with us. Welcome back to Weather Extra. We stay with our international weather coverage tonight and turn to the country to our south. Mexico got hit with not one but two powerful earthquakes over the past week. Let's check them out. Now, the first earthquake of the week hit in western Mexico back on Monday, September 19th. The first quake had a 7.6 magnitude and killed at least 2 people, damaging buildings, knocking out power, and sending residents of Mexico City scrambling outside for safety. The outside of this department store in western Mexico suffered severe damage after the quake. Part of the store's exterior wall fell on vehicles parked outside, leaving at least 3 cars destroyed. These earthquakes rumbled across Mexico on the same day as the destructive earthquakes battered the country in 1985 and also 2017. Thousands of people were killed in 1985 earthquake and more than 350 people died in the 2017 quake. The second powerful earthquake struck western Mexico again this past Thursday, September 22nd, early in the morning. Now, this quake did hit just 3 days after the first. Although this earthquake wasn't as strong as the one earlier in the week, it was still very powerful, having a 6.8 magnitude. At least 2 people died. Some landslides were also set off along the coast on local highways, and some damage was reported to buildings. And that's all we have for you here on week 3 of Weather Extra. Thank you for staying up late with us tonight. Make sure to tune right back in here next Sunday at this exact time, right after the 10 p.m. newscast. Good night and have a great week.